Imagine a world where your digital devices don't just sit in your pocket, but actively engage with the world around you. This is the essence of spatial computing, a revolutionary field that's changing how we interact with technology. Spatial computing is all about merging the digital and physical realms, making it possible for computers to understand and interact with their surroundings in a way that feels natural and intuitive. At its core, spatial computing uses advanced sensors, such as cameras and LiDAR, to map and track the physical environment in real time. These sensors create a detailed 3D model of the world, which the system then processes to place digital objects and information accurately within the physical space. For example, imagine a virtual furniture app that lets you see how a new couch would look in your living room before you buy it. The app uses spatial computing to ensure the digital couch fits perfectly in the real space, taking into account the dimensions and layout of your room. One of the most exciting aspects of spatial computing is its ability to enable natural interaction. Instead of relying on a mouse or keyboard, users can control digital content using intuitive gestures, voice commands, and even eye movements. This makes the technology accessible and engaging for everyone, from tech enthusiasts to those who might find traditional interfaces intimidating. But here's where it gets really interesting. Spatial computing doesn't just overlay digital content, it creates fully immersive experiences. Think of augmented reality (AR) and mixed reality (MR) applications that blend the real world with digital elements. For instance, a museum exhibit could come to life with interactive digital overlays, providing visitors with a deeper understanding of the artifacts on display. Or, in a more practical setting, a surgeon could use AR to visualize a patient's anatomy during a procedure, enhancing precision and safety. Spatial computing is an umbrella term that encompasses several cutting-edge technologies, including virtual reality, VR, augmented reality, AR, and mixed reality, MR. Each of these technologies has its own unique applications, but they all share the common goal of bridging the gap between the digital and physical worlds. One of the most powerful applications of spatial computing is the creation of digital twins. A digital twin is a virtual replica of a real-world object or environment, used for simulation and analysis. For example, engineers can create a digital twin of a city to simulate traffic patterns and optimize infrastructure. In healthcare, digital twins can be used to model a patient's condition and test different treatment options without any risk to the patient. Another key feature of spatial computing is its contextual awareness. The technology can understand objects, surfaces, and spaces, allowing it to place digital content in a way that makes sense. For instance, a virtual pet in an AR game would know to walk around obstacles rather than through them, making the experience more realistic and engaging. Perhaps the most transformative aspect of spatial computing is its potential to move computing beyond traditional screens. This opens up a whole new world of applications, from gaming and education to design and healthcare. Imagine a classroom where students can explore historical sites in AR, or a design studio where architects can manipulate 3D models with their hands. And this is the part most people miss. While the benefits of spatial computing are clear, there are also concerns about privacy and security. As our digital and physical worlds become more intertwined, how do we protect sensitive information and ensure that our interactions remain private? These are important questions that need to be addressed as the technology continues to evolve. So, what do you think? Is spatial computing the future of technology, or are there too many challenges to overcome? Share your thoughts in the comments below, and let's start a conversation.